Hi everyone, we're going to go over different kinds of plots today. So in the file section on our Canvas page, again in the exam 1 material, you'll find an R text file for plots and descriptive statistics. So you can go ahead and download that text file, and that's what we're going to be looking at today. This says plots and descriptive statistics. Today we're going to be looking at just the plots. All right. So once you have that text file open, I'm going to just copy and paste everything into RStudio directly to work on. Okay. And scroll to the top, and I'm going to clear this console down here with this broom to clear all of this text so I have a clean working space. So we're going to talk about a few different kinds of charts today. We have pie charts, bar graph, Pareto, which is a type of bar graph, histograms, stem plots, and time plots are what we're going to be looking at. And then everything after that, once we start getting here, is going to be for next time. Okay, so let's start with a pie chart. So a pie chart is kind of how it sounds. It's circular shaped like a pie, and just how you cut pies into different slices. This is a graph where we have a circle and we cut it up into different slices. Those slices represent the proportion of data points or observations within each of those different groups. So the slices make up different groups, and you'll see that in a visual here in a moment when we generate this. So let's see how we can make a pie chart in R. So again, I'm going to create my data. Anything that I have an arrow pointing to, that means I'm going to save. I'm going to save slices. Slices is going to be a shortcut for this set of data here. So instead of typing this data over and over, whenever I talk about slices, it is referring to this data set here. So this is numbers which are percentages, and that's how it's going to be used in this problem. 10.6%, 14.7%, 14.5%, 5.2%, so on and so on. And what this is going to amount to, we're going to assign labels to these slices. I have labels abbreviated LBLS. I don't have it typed out all the way, and that's because when we're doing the codes, the word labels is actually a argument here. What we can do instead, if you don't like this abbreviation, you can call it something else. Like instead of labels, LBLS, we see these are different areas of study: art, biology, business, education, engineering, and so on. If you don't like that abbreviation, you'd rather it be a full word, you can certainly do it. These are areas of study, so I'm going to call this maybe subject, the subject that we're going to study. And then you'd have to change it accordingly here. So a lot of how these problems go, the problems when you're doing homework, it's going to be taking the R code that we talk about and just copy, pasting, and modifying it. So I'm setting up this data, 10.6%, 14.7%, so on and so on. It's going to say there are 10.6% of people that are studying in the arts, 14.7% studying biology, 14.5% studying business, and so on and so on. So I'm going to go ahead and click run on these two. So now I have slices and subjects saved. So again, I could write out slices and subject, and this is what they are. Slices are all these percentages, and then subjects are the different subjects people are studying. And we're going to make a pie graph of this. And to make a pie graph, we use the command pie, P-I-E, pie, to make a pie graph. The data we use for the pie graph comes from our slices. So you specify the data you want to use and the labels you want on each of the slices of the pie. So the labels are going to come from a subject, which are these subjects that we made here. And what this next piece is optional. If you delete this and delete the comma, it'll still run, but but what this main does, main means you're adding a title. So you want the title to be whatever you want to call it. This is going to be pie chart of field of study. We can go ahead and click run, and what we see is that a pie chart pops up in this panel here. So this is what a pie chart will look like. We have our title, pie chart of field of study, that comes from here. And we have all of the different slices and the percentages. For instance, we see the art slice here that takes up 10.6% of the pie. Biology takes up 14.7% of the pie, so on and so on. So we have the slices and all of the labels. And if you wanted to, you could click this zoom to zoom it in if you want and rescale it. My screen isn't super large, and this is going to rescale proportionate to your screen that you're looking at. And because I can't make this super big, you see I have this little conflict of labels here. Math and physical science, the labels are not organized in a very pretty fashion. There's things you can do to fix that, but we're not going to worry about that for now. Right now, the whole goal is just to get a basic pie chart going. Now, what would be really cool is in all of these slices, in addition to having the labels here, it'd be really cool to print out the percentages also. So what we're going to do is we're going to modify these labels to include the percentages also. And that's what we have going on over here. So we have our slices, right? And this is, again, an example where we're feeding it all of the percentages. So we're saying we already know 10.6 belong to the arts, 14.7 belong to biology, so on and so on and so on. That's different than saying we know there are 110 people in the arts, 153 in biology. That's a different problem that we're going to do next. But right now we're going to fill in these labels. So we have slices. This is the same data. We have our labels. Again, we renamed it up here subject. If you wanted to rename it as subject, you can. Okay, that's up to you. I'm going to keep this consistent. I'm going to change these all to subject anytime I see that, and this is completely up to you if you want to change this, if you don't like these kind of abbreviated terms like LBLS as an abbreviation for labels. So we have our subject, and now what I'm going to do is I'm going to use this paste command. So I'm going to update my subjects to paste together the subject and the slices. So it's pasting together everything in here with everything in here. So what that's going to do, it's going to update my subjects to say not just art, biology, business, education, but it's going to glue these two things together. It's going to glue this together with this together with this together with this, and so on. So instead of it just saying art, biology, business, education, so on, it's going to say art 10.6, biology 14.7. We're pasting together subjects with the slices. Okay, so right now, if I typed out subject down here, you would see the output looks like this. But when we update subject by running this line, when we update it, and now we type out subject, we get art 10.6, biology 14.7, business 14.5, so on and so on. And what would kind of complete this is if we had a percent symbol attached to this number here. And that's what we're going to do. And notice by default, what we have here is we have arts and then a space and then the number. Biology, space, and then the number. By default, when we paste together two things, it's going to insert a space in between them. If you want something different than that, you have to specify. So in this next line, when we're updating this subject again, we're going to paste together the subject, which again is the new one with these numbers, and we're going to paste it with a % symbol. And we're going to specify how we want them to be separated. Before we saw it separated with a space by default in between all of these. And I have SEP for separate, and I have these empty quotes with nothing in between. What you want to separate it with, you put in the quotes. And notice I have nothing inside of the quotes. So it's just going to tack that on without any space or anything in between. So I'm going to go ahead and run that, and now you see when I type out subject, it appended the % symbol without a space in between that and the number. So now when we run the pie chart, we see pie chart of field of study. Now all of these have the subject and the percentage. So you have a more informed pie chart here. Notice these colors are more vibrant too, and that's because I edited the colors a little bit. I specified the colors with this command rainbow. This is completely optional. If you delete this, it'll give you those same color scheme before, right? I have this arrow to go back and forth between the plots that I've made. If I didn't specify this color thing, then it would give me by default these colors, and that's fine. This is just to show you that R can do some things to change how the graph looks. And what this does is you say, okay, how many colors do you want? Right, there are 1, 2, 3, 4, 5, 6, 7, 8, 9. There are 10. So I'm going to pick 10 colors. And remember the length command we saw before says how many entries you have in a list. So length of subject is just 10 here, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We have 10 slices. So if we deleted this and just put 10 manually, we could. If you didn't want to go through the hassle of counting by hand, you could just put this and it'll count it all for you. Something interesting is that if we look at just this, you'll see how R recognizes colors. I'm going to go ahead and run this. And we get all of this information. So the way R identifies colors is by these color codes. So these color codes by themselves don't really mean much looking at them. You know, what does FF stand for in 0000, CCFF00? There's no way of looking at this and knowing exactly what colors these give you without knowing the color codes. So on the back end, R recognizes colors by certain specific color codes, and different shades of a color, different shades of green will have the color code different. R does recognize some basic colors like red, green, blue, things like that. But if you wanted more specific colors with specific hues and shades, you'd have to find exactly what's the color code for that. All right, I'm going to go ahead and clear my console down here just to have a clean slate. So that was pie charts where we know the percentages already, right? So now what if you don't know the percentages? So I'm going to look at an example of these are days of the week babies are born. So for example, this is going to say 7,134 babies were born on Sunday 1 year, or in a month, or in a week, whatever time period this is over. 11,430 were born on Monday, 12,387 were born on Tuesday, and so on. So I'm going to go ahead and run these. And I'll just keep this label as it is for now. If you want to change it to say, you know, the weekday or something, you are more than welcome to. And when we do the pie command, we still feed just the data. Before, the data was the percentages, but now we're feeding just the raw observations. And what you'll notice is when we run this, it calculates the percentages and scales it all for you, even though you're giving it the non-percentage values. So the trick, though, is that since before these were already percentages, we were able to just paste them right on to get the percentages. Now, since we don't have that, we have to calculate what the percentages are manually. So that's what's happening here next. PCT for percentages. You can name this whatever you want. And what I'm doing is to calculate the percent, I take the value, divide it by the total, right? Sum gives you the total, and then times by 100 to get it to a percentage. And then I'm rounding that number to 1 decimal place. So I'm going to click run on that, and when I type PCT, I get these. So 9.4%, 15.1%, 16.4%, so on and so on. So again, if you wanted to recreate these numbers, let's see what that would look like. The sum of the slices, meaning the total, is 75,660. So if you wanted to figure out what percent of them were born on Sunday, you would look at the Sunday value, 7134, divided by the total, 75,660, and then multiply by 100 to get it as a percent, and you get this 9.4, and there's more decimals after that. And we rounded it to 1 decimal place, and that's why it stops at 1.4. So this is the process it's doing for each number. We're just doing it all in one line. Each of the slice values divided by the total times 100, and then rounding that to 1 decimal. So that's where these numbers are coming from. Now that that's set up, we can play this same game of pasting together to get the percentage labels. So the labels I'm going to update, I'm going to paste together the labels with the percents. So now when I look at labels, I get Sunday 9.4, Monday 15.1, Tuesday 16.4, and again there is a space in between them when I pasted them together. If you don't specify how you want them to be separated, it's going to default it with a space. Now we can append the percent symbol and separate it with nothing, because there's nothing inside of these quotes, right? It's empty inside. I don't have a space inside the quotes, right? It's just empty quotation. So it's going to put this at the end of it without putting anything else in between. So I'm going to run that, and now when I look at my labels, I see the percentage symbol on there. Now I'm going to go ahead and run my pie the same way. My data, my labels, and if you want to change the colors, and here is the title. And there we are. We have the pie chart with a different color scheme than we did before. You know, there's these more pastel colors, and now we have more vibrant colors. You can pick them how you want. But we have pie chart, we have the days of the week, and now we have the percentages, right, which we didn't start with, right? We started with the number of babies on each day. We didn't start with the percentages. We calculated them to get a better visual of the table here. So moving on, next comes the bar graph. I'm going to go ahead and clear my console here. So the way bar graphs work is you have different groups that you group into bars, and bars on a bar graph do not touch. The columns of a bar graph represent groups or categories, right? Not necessarily numbers. So I'm going to walk through a couple examples of bar graphs. Again, the bars represent groups, not necessarily numbers. So I'm going to create this data here: 2, 3, 3, 3, 4, 5, 5, 5, 5, 6. I'm just calling it H. Why not? Okay, so H is this list of numbers. And notice every time I have something with an arrow pointing to it that I create, it pops up here to help keep organized everything you have saved. Now what I'm going to do is the command counts, and what this is going I'm going to create something called counts using the command table. And what table is going to do, it's going to count how many of each item there is. For example, how many 2s are in here? 1. How many 3s are here? 3. How many 4s? how many 5s, how many 6s. This is going to count that all for me. The table command will count that out, and I'm going to save that as counts. I'll run that, and now we can look at what counts looks like. So this is saying there is 1 2, 3 3s, 1 4, 4 5s, and 1 6. Okay, so if we wanted to make this into a bar plot, we can use the command bar plot. And again, bars on a bar graph or bar plot do not touch. The columns represent categories. You know, I do realize I'm using numbers here, but I'm talking about not necessarily in an accounting way, 2 3 4, but more just as labels. For example, you know, I could easily change this to red, red, maybe blue, 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 green, red, blue, 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 green. Let's do yellow, 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 and now maybe it's another color: red, green, blue, yellow, let's say pink. Right, run, and now when I run counts, it's going to count how many of each of those there are. So this is saying there's 3 blue, 1 green, 1 pink, 1 red, and 4 yellow. All right. And notice it sorted this in alphabetical order, not in the order they appear. And if I wanted a bar plot of that, notice that the columns are here. All the columns are the same height, but they're in different order, right? Because this sorted it by, it sorts by alphabetical, but dealing with numbers least to greatest. And here the bars are the same height, it's just in a different order because it sorted it in alphabetical here. So again, the big takeaway: bars on a bar graph do not touch. The columns represent different groups or categories, and this vertical axis here determines how many are in. This says how many are in each group. So in the blue group, the graph says, okay, there's 3. In the green group, there's 1. In the pink, there's 1. In the red, there's 1. In the yellow, there is 4. Let's make another bar plot. Okay. I'm going to create data. I'm just going to call it B. All right. So the example we did before, we counted how many were in each of the groups. We fed it the different groups. You know, maybe there was 1 red marble. We pulled out 3 blue marbles, a green marble, 4 yellow marbles, and a pink marble from a jar or something. And we wanted to make a box plot to describe the distribution that we see. Okay. We could feed it as the data being exactly these numbers. You know, there's 3 in one group, 1 in these groups, and 4 in this group. We can have the data be exactly the heights of the bars. So in the next example, I'm going to make my data, I'm calling it B. And when I feed in the data directly, what that's going to do is it's going to say, okay, you want your first bar to be 3 units high, your next one to be 2 units high, 25 units high, so on and so on. I'm going to click run so we can see how that looks like. But remember, main is what gives you a title. You can specify a label on your x-axis. Here I have it called letters. You can specify a label on your y-axis with YLAB for Y label and XLAB for the X label. And then notice before we started with this and the names showed up in the table. And that's because we started with the raw data and not the number in each column, the number of observations in each column. So because we have it set up differently where we're feeding the command the number of observations in each column, we have to name the x-axis here. And the way we do that is, or we have to name the columns here, the groups. The way we can do that is with names.arg, okay? And we specify that to be whatever we want to name the columns. I just named them A, B, C, D, E, F, G, whatever you want to name them. And this brings us to what we call a Pareto chart. A Pareto chart is a special kind of bar graph where the bars are ordered from tallest to shortest. So if we wanted to do that, we could use the sort command, right? Bar plot, and instead of B, we can sort B. We saw this sort command last time with decreasing equals true, and so that's going to sort them accordingly. And what I didn't do is I did not reorder these, but you certainly could, right? These columns still show up in the same order. You certainly could reorder those labels. Now, very similar to a bar graph is a histogram, and in a histogram, the bars do touch, but the bars don't represent categories, they represent ranges of values. And something cool that we can do is we've been typing in all of our own data into R, but we can actually read data from other sources. So in Canvas, you see there is a college data set that you can go ahead and download. All right. And what's going to happen is when we run this command, what's going to happen is a Windows going to pop up where you can then look through all your files. Sorry, I'm recording this on my computer and I have tons of files that aren't relevant, so I moved it off screen. Tons of files, and you can go ahead and search through that browser to find exactly the data set you're looking for. So once you find your data set, wherever you have it saved, you can just select it and import it into R. Okay, so now we have this data set. I called it MD for my data because I just want to be easy, and I always call it my data because I'm lazy. And we saw that it popped up over here, right? And we can click on that and it'll give us a preview of the data. So I just clicked on this, and it has a year versus college tuition. And this is what we're going to make a histogram of. So to make a histogram, we can use the command hist, H-I-S-T, for histogram. And now we're referencing a data set. Instead of a list of data that we created, we're referencing a data set, okay? And if you want to reference a specific column in a data set, right, we're going to look at, tuition here. If you want to look at a specific column in a data set, you have to specify it with a $sign, okay? So MD to refer to the data set, and then $sign tuition to specify the exact column. And notice it matches, it has to match perfectly, capitalization, spelling, everything perfectly. And just because I can, I'm going to specify the color to be green. Remember before I said that R recognizes colors as these complicated color codes, but there are some simple colors that it knows. And here we have a histogram, and you could edit the title and the x-axis and the y-axis if you wanted, with the x label and y label commands and main. But here we have our histogram, and the bars on this are touching. Remember, bars on a bar graph do not touch. Bars on a histogram do touch. And these are ranges. So this is saying there were 6 years where the tuition was between $2,000 and $3,000. There were 7 years where the tuition was between $3,000 and $4,000. There were, I don't know how high this goes, probably 9 or 10 years where it was between $4,000 and $5,000. 2 years that it was between $5,000 and $6,000. And this is a continuous scale, right? This could be any number between $2,000 and $3,000 that falls in here. The only trick is that if you wanted to know, for example, if you had 1 year where tuition was exactly $3,000, would it fall in this one or this one? Well, actually, it would fall into this one. So when you see these ranges, 2,000 to 3,000, what that range includes is everything starting at the first number, but less than the second number. So anything that is specifically less than 3,000, so $2,999.99 would fall into here. But as soon as you add one more penny and go to $3,000, then you are an observation in this column. And something very similar to a histogram is what's called a stem plot. So we're going to make a stem plot of the data. Again, the command stem, and you specify your data set, $, the column you'd like to look at. And something interesting that you see is here is the stem plot, and it says, it gives you this little key. The decimal point is 3 digits to the right of the vertical bar here. So what that means is 2 bar 3. What that means is, if I typed it here, 2 bar, I'll comment it out, 2 bar 3 means, okay, the decimal is 3 digits to the right of the bar. Okay, so if we took that bar and moved it 3 digits over, 1, 2, 3 digits over, that would be 2,300. So 2 bar 3 means 2,300, 2,300, 2,500, 2,700, 2,800, 2,900. These are all of the values that make up the first bar here. Notice there's 1, 2, 3, 4, 5, 6 of them, and this is 6 high. This would be 3,000, 3,100, 3,100, 3,200. And notice these are all rounded values, right? The tuitions, are not nice round numbers, 2,300 and so on. 2,274, that's rounded to 2,300, for example. So notice if you took this picture, this plot, and you rotated it counterclockwise 90 degrees, the heights of all of these would match the height of this, and you can kind of take a moment to visualize that for yourself. If I rotated this 90 degrees counterclockwise or anti-clockwise, the bars of the histogram would match the same shape as these bars here. Now, there's a couple ways we can describe the shape of a histogram. If there's a big hump over to the right hand side and it starts to get really small and tail off to the right, we would call that right skewed. If it was the reverse, a big hump on the right and then starts to taper off and become smaller and smaller towards the left, you would call that left skewed. And if it's about centered, not a big bulge to the left or a big bulge to the right, but centered, right? So maybe it starts off really, really low, gradually increases to a hump, and then symmetrically goes back down. We would call that a normal distribution. And if all of these bars were about the same height, we would call that a uniform distribution. So those are the 4 big ways to describe distributions. Distributions are described as left skewed, right skewed, normally distributed, or uniformly distributed. And you'll start to see some examples of these in your homeworks. Next, we're going to look at a time plot. So again, this is an example of, this is called time series data. Time series data. This is an example of plotting time series data. So time series data is data where where you're looking at one or more variables over time, right? So we have one variable, which is time, the year, and we're looking at this other variable over time. The plot command will allow you to plot something. You specify what you want on your x-axis, followed by what you want on your y-axis. So we're going to look at year on the x-axis. Remember, you refer to a data set as the name of the data set that you have in R. We called it MD. MD for my data is how I usually refer to that, just to be simple. $sign to specify which column you want to look at, which column or which variable you want to look at. You can call these columns, you can call these variables. And then comma, what you want to look at on your y-axis, which is tuition. And this will give you a plot of tuition over time. This is a dot plot. If you wanted this to be a line plot instead of a dot plot, what you can do is use this command type equals L. This is a letter L, not a 1. This is a lowercase letter L. We can specify type equals L to, instead of give us all of these as dots, it gives us it as a line plot. It connects all the dots with lines. So we can see the trend over time with this. We can see the general trend. As we all know, without a graph needing to tell us, college tuition has been increasing over the years. We could give a label to the x-axis and the y-axis. X label, we call it year. That sounds fitting. Y label, we can say tuition cost, and we're talking about in dollars and USD dollars. And now it looks a little nicer. We have year there and then tuition cost. And lastly, you could give it a title if you wanted with the command main. Tuition versus time. And this is a time plot. We're looking at specific data over time. We can see the general trend and how it grows. And this is the type of plot that's used in just about any industry you could think of, right? A lot of places are looking at trends over time. So this is enough to start working on the next homework assignment. Next time we're going to talk about the descriptive statistics, which is the rest of this file. But for now, we have these all of these different plots. So your next homework is one where you have to do a certain number of creating each of these plots. Please do let me know if you have questions on anything. Feel free to email me and I will get back to you. Thank you.